Hello everyone, this is Dr. SUNITA M. Today we'll study about formal languages and automata theory. That is introduction to finite automata today. So these are the outcomes of a formal languages and automata theory. That is, the students will be able to understand the concept of abstract machines and their power to recognize the language, employ the finite state machines for modeling and solving computing problems, design context-free grammar for formal languages, and learn normal forms, design the Turing machine. So outcomes of this subject are this. So this is just an overview of the syllabus. So first unit, it is an introduction to the finite automata, where they'll study about the structural representation of a DFA and FA strings, languages, and with the epsilon transitions. And unit 2 is regular expressions like finite automata and regular expressions, applications of a regular expressions, pumping lemma, and regular languages, equivalence of a minimization of automata. And unit 3 is context-free grammar, like definitions of context-free grammar, derivations, leftmost and rightmost, derivations, ambiguity, then push-down automata, languages, equivalence of a push-down automata. Unit 4 is a normal form of a context-free grammars. Unit 5 is introduction to the Turing machine. Textbook which we can refer is Introduction to Automata Theory, Languages and Computation, that is John E. Hopcroft. And second is Theory of Computer Science, that is Mishra and Chandrasekharan, that is second edition. And reference books are Introduction to the Languages and the Theory of Computation, John C. Martin, TMH, Introduction to Computer Theory, and that is John Willey, and textbook on automata theory, that is Srimani Nasri. Let us start. So what is finite automata? So finite automata is nothing but what? An abstract machine which is used to recognize the patterns in an input sequence, forming the basis for understanding the regular languages in a computer science, which consist of states, transitions, and input symbols, processing each symbol step by step. If ends in an accepting state after processing the input, then the input is accepted, or else it is rejected. So finite automata comes in deterministic finite automata and a non-deterministic finite automata, both of which can recognize the same set of regular languages. So these are widely used in text processing, compilers, and network protocols. So here is just a overview of a finite automata. You can say it as a block diagram. So which consists of an input, state of an automata, and output. So I1, I2 till In are the inputs, and state of automata, that is states, how many states will be there, Q1, Q2, and a Qn, and outputs O1, O2 and a ON. So just see features of a finite automata. Input. What is input here? So set of symbols or characters provided to the machine. And output. So output is just which accepts or rejects based on the input pattern. So state of automata, the conditions or configurations of the machine. So state relation, the relation is the transitions between the states. Okay, these all you'll know while we'll solve a problem. So output relation is based on the final state, the output decision is made. So basic definitions of a symbol. A symbol is the smallest building block which can be any alphabet, letter, or a picture. Example can be A, B, C, or else 0 to 9 symbols we can use. Okay, that is for a transition input symbol, we are going to use this. Okay, alphabet. What is an alphabet? An alphabet is a finite non-empty set of a symbol. It is denoted by a sigma. So example here are, see first A, sigma is equal to 0, 1. This is nothing but what? Set of a binary alphabet. Sigma is equal to A, B, Z, the set of all lowercase letters. Okay, and sigma is equal to plus, and so these are what? Special characters. String or a word. A string is a finite set of a sequence of a symbol chosen from a some alphabets. So example, that is length of a string we are going to say. So length can be anything. It can be 0, 1. It depends. So string is nothing but what? Whatever the length will be there. So here a 0, 1, 1, 1, 0, 1, 0. So this we'll say it as a string. So how in which length it is, how much length it is? 0, 1, 2, 3, 4, 5, 6, 7. Length of the string is 7 here. So this is a string from the binary alphabet, that is 0, 1. We'll say it as 0, 1. Sigma here. What are the input strings we are going to use? Here is 0, 1. If it is in the form of a AB, okay, or else C you can also take. So for example B, you can see here AABB AACAB. This is also a string. Length of the string depends of how many characters we are going to use. So here input symbols are A, B, C. If we are going to use only A, B, the symbol input symbol will be only A, B, not C. Okay, so next, empty string. Empty string is nothing but what? It does not contain any string. So here the empty string is a string with a zero occurrence of a symbols. So it is denoted by epsilon. Length of the string, just now I said length of the string is nothing but what? How many characters, or else how many this thing has occurred. So the length of the string is nothing but what? Number of symbols in the string. It is denoted by mod W. So example W here is 0, 1, 0, 1, 1, 0, 1, 0, 1 from a binary alphabet. So here symbols we have used, input symbols is 0, 1, and the length of the string will be 9. Next, formal definition of a finite automata. So which consists of a 5 tuples, that is M is equal to capital Q, sigma, small q, F, and a transition. What are these symbols? Okay, Q is nothing but what? Finite set of a states. And sigma is set of a input symbol. So input symbol just now in the previous slide we have seen here, that is 0, 1, A, B. Those are nothing but called as input symbols. Okay, next Q here is initial states, that is a start state from which we are going to start. Okay, and F is nothing but what? Set of a final states. How many final states are there, or else which state is a final state here. Next, transition functions. Here types of finite automata are, there are two types: DFA, that is deterministic finite automata, and a non-deterministic finite automata. What is deterministic finite automata? In deterministic finite automata, what is going to happen is, from one state with one input symbol, it reaches to only one state. Okay, but whereas in non-deterministic finite automata, from one state with one input symbol, it will reach to more than one state. Okay, that is nothing but what? Non-deterministic finite automata. So this is the main difference between DFA and NFA. So DFA we'll study now first, which is represented by 5 tuples, that is Q, sigma, small q, capital F, and transition symbol. So for each input symbol, the machine transitions to one and only one state. Right, from one state with one input symbol, it reaches to only one state. So DFA does not allow any null transitions. Okay, no null transitions are entertained here. So meaning every state must have a transition. Okay, defined for every input symbol. So again 5 tuples. So these are the 5 tuples. The Q is a set of all states, set of input symbols. Small q is the initial state, that is a start state. F is a final state, and transition function. Okay, example. We'll solve some examples now. Okay, first, construct a DFA that accepts all strings ending with A. Okay, all strings ending with A means what? What are the possible strings here? See. Okay, ending with A, just we can take it as A, right? Then BA. What are the possibilities? ABA, because they said here is ending with A. Just all whatever the possibilities of a strings you can write, but it should end with A. AB, ABA, BB, A, B, A, anything it can be. Okay. So now the length here is, can be anything. It can be 1, 2, 3, 4, 5. Okay. And input symbols are A and B. We are here using here is A comma B. Okay. Can we, we'll draw the transition diagram. How many states we require to represent this? Only 2 states, because the set is ending with A. So 2 states, Q0, which will be the start state, and Q1, which we can take it as a final state. See here, the states, how we are going to represent is inside a circle, right? Inside a circle, and states here we have taken is Q0 as well as Q1, and this arrow mark indicates that transitions, and arrow mark with the symbols, this is input symbol. So Q0 on A, it is going to Q1, right? That is nothing but what? Transition. Transition of Q0 with the input symbol A, where it is going? Q1. So here it is ending with A, right? So ending with A means Q0 we have taken with A, and Q1 it reaches to the final state. But here there are 2 input symbols, A comma B, right? So from each state we need to check for both the combinations, A as well as B. Now Q0, A is done. What about B? Where I should take Q0 on B? Because they said this ending with A, but they didn't say that it starts with A. So B we can take here as a loop, right? B, if we take a loop, loop indicates what? May or may not. Okay, it may occur or it may not occur. So it can start with B or else it can start with A, right? Possibility. See here, length of this inner length, you see here, B, A is there. If it starts with B, it takes a loop B and ends with A. If it is A, B, A, again, that for 3 combinations we need to check. So for Q0, A and B is over, right? Next for Q1. What about Q1? Because what did they say is ending with A. Ending with A means Q1 I can take it as A, because if loop indicates that may or may not, and we have taken here A. What does that mean? That it can end with A. This A or this A, right? N number of A's. If it comes, then we can take this A loop. Okay. So Q1 A is over. Next, what about B? Where I should take? If I take a loop here, B input, possibility is that it will end with B. A is here. If this loop, if it takes B, then it may end with B, right? Like A, B. But B is not allowed in this, because they said is ending with A itself. Hence, B should not be there. Right? Only A should be there. So what about B? Because in DFA, from one state, both the input symbols should be there and it should reach to only one state. Now Q1 is there. Q1 A is over. What about B? Okay, B I can't take it as a loop. So just I'll take it as a here. Once check. Q1 on B is going to Q0 again. Right? But it is not ending with A, because Q1 on B it reaches to Q0, but to reach to the final state again it should end with A here. That is small a. Understood? So Q0, A is Q1, B is Q0, Q1, A is Q1 and B goes to Q0, but to reach to the final state it should go again back to Q1 with the input symbol A. This is how we need to draw the transition diagram ending with A. Okay, and write all the 5 tuples. So what are the 5 tuples? Capital Q. Okay, Q0, transition function. Next, final state and sigma. So what is here sigma? Indicates what? What are the input symbols we are going to take? That is A, comma B. Next, capital Q. What is this capital Q is? How many states are present here? That is Q0, Q1. Next, F will take. F is nothing but what? Final state. The one with a double circle is nothing but what? A final state. That is Q1 here. Next is over Q0, small Q0. So Q0 is nothing but what? Start state. So start state here is what? Q0 only. Right? Next, transition. So transition of Q0 on A, transition of Q0 on B, transition of Q1 on A, transition of Q1 on B. Okay. So Q0 on A is what? Q1. Q0 on B is what? Q0. Q1 on A is what? Q1. Q1 on B is Q0. Okay, this is the transitions, and we can write this in the form of a table. That is state as well as input symbol. This is okay, input symbol, and how many states are there? 2 states. And which is the start state? Q0. And which is the final state? We need to represent like this in the table. Q0 on A is what? Q1. Q0 on B is what? Q0. Q1 on A is what? Q1. Q1 on A. Q1 on B is Q0. Okay. So this is how we need to write the transition table. Now to check whether whatever the string we have taken, whether that is accepted by this transition or not. We need to check for acceptance. Okay. Language acceptance. How to check that? Just example, we'll take this. That is B, B, A, B, A, or else. Okay. This string we'll take and we'll check for this. Transition of B, B, A, B, A. Okay. Start state is what? Q0 here. B, B, A, B, A. Okay. Q0 on B is what? Q0 on B? Q0. So B, A, B, A. Next, Q0 on B is what again? Q0. A, B, A. Q0 on A is what? Q1. A, B, A. Q1 on B. Q1 on A. Q1. Q1 on B. Q0. A. Q0 on A. Q1. Q1, A. Q1 on A is what again? Q1. So this is nothing but what? A final state. So this language is accepted by this transition diagram. Understood? Okay. Next, one more example we'll take. Construct a DFA that accept all strings starting with A. Starting with A here. Previously ending with A. Here it should be what? Starting with A. So how many states we require for this to represent again? Q0, Q1, 2 states, and this is A. Start state. Okay. Starts with A only. It will not start with B. Okay. What are the possible length of the strings? See here. What are the strings, possible strings? A. Starts with A, ends with B. Or then AB. ABA, ABB, AB. Okay, remember. Here what? It starts with A. Here it can be anything. Any string, any possible string. But it should start with A. Okay. So Q0 A goes to Q1. And if it starts with B, possibility is that it may start with B. Then we should take a state, one more state, which should not reach to the final state. Okay, this is B, and what? Say Q0 A is over, B is over. B is a dead state here, so Q2 will take AB input as a here only, and as this is not reaching to the final state, that is Q1, so it remains in Q2 only, and it will not start with B. Okay, only it starts with A. And what about this Q1, A and B? See, Q naught A is over, that is starting, and after this it can be anything. So we will take it as a comma B, right? So Q1 with A, it remains in a Q1, Q1 with B, again it remains in a Q1 only. So next, write all the 5 tuples. What are the 5 tuples again? Transition, Q naught, capital Q, sigma, and a final state. So what is here? Q naught, which is the start state here, Q naught only. And what is this capital Q? How many states we are going to take? Q naught, Q1, only 2 states. What is the input symbols we have taken here? A comma B. And what is the final state here? Q1. This transition table we'll write here now. How to write the transition table? A, B, and how many states? Q naught, Q1. Okay, start state is this, end state is Q1. Q naught on A is what? Q1. Q naught on B here is Q2, which is a dead state. Okay, and Q1 here on A is Q1. Q1 on B is Q1 only. This is how we need to write the transition table. Next, how to check the language is accepted or not? Again, repeat that process. Okay, just we'll take this string, that is A, B, A, B, A, B. Okay, we'll check this whether this is accepted by this transition diagram or not. Starts with Q naught state, A, B, A, B, A, B. Okay, Q naught on A is what? Q1. Okay, next Q1 on B is Q1. Q1 on A, Q1. Q1 on B, Q1. Q1 on A, Q1. Q1 on B, Q1. So this is the final state, right? So this is how we need to draw the transition diagram for the given quotient, that is condition, and we need to check the acceptance for that particular language or the string. Okay. Thank you.